What's up, guys? I'm in my buddy's RV and we just replaced the converter charger here. There was originally a Magnetek that was from like 2001, which had a linear transformer in it, and we found that the standby power was like 50 watts. The efficiency of it was like 52%. The power factor was 0.5, and on top of that all, it was only putting out like 120 watts into the battery. So while it did take the batteries up to 100% charge, it took like 3 days to get a set of lithium iron phosphate batteries charged up. So anyways, we cut that thing out of there. It was in this bottom section here, but I actually wanted to keep the housing for it. So I gutted the housing and then I cut the back of the housing off. So it's open to the back now, but I kept the metal floor part and I kept this bracket part because I needed this section here for these panel screws. So then I installed this guy down inside. Actually, I cut some of the sides out as well, so that I could fit the gigantic terminals here, the DC side. And I still have access to the dip switches. You can, in the way back there, you can kind of see there's three little white switches back there. Those are the dip switches. I have them set where I want them now. But so I do have access to that. And there is a on and off switch here on this side, a rocker switch. This is the NPB 75012 from Meanwell, and it promises to be 0.98 power factor, and it said 93% efficiency, and it's going to put out 43 amps on the DC side. So once we got it all hooked up and tested, sure enough, instead of a 50 watt standby power like the Magnetek, this thing has like a 1.5 watt standby power. And I have it on breaker number 4 here, so I can turn it on and off that way too. Because when I'm on the inverter, obviously if I turn this thing on, it's going to charge itself from the battery bank. So you want to have a switch to control that, and I'm not going to have access to that rocker switch because the panel will be covering it. So easy access is breaker number 4. Turn this thing on and off. When you're on shore power, it'll automatically give priority to shore power. When I'm on it, if I have an inverter power and shore power available, I want to give the shore power priority, and then I can use that to charge the battery banks. So anyways, I was not disappointed when we test this. It was about 90% efficient, which is probably because we're on 120 volts power, not 240. It's probably saying that it's 93% efficient on 240, or I assume. But 90% is a lot better than 50%, and the power factor was 0.98 as promised. And that's a huge improvement too, because you're not pulling as many amps on possibly a sketchy extension cable or a sketchy outlet somewhere. I mean, you can literally plug this into any old, plain old extension cord, and it's only going to draw like 5.9 amps on the AC side. So that's a nice improvement there. When you have a bad power factor, it draws a lot more amps, and that can really max out a 15 amp situation. And so I also had before, like the Magnetek was sending its DC power up here into this DC panel through the back, and then it would go from that over to the solenoid, and then from the solenoid to the batteries. I didn't really like that. I didn't want to send my 43 amps through all that crap, so I actually wired this with 6 gauge directly to the battery bank, which the battery bank is right here on the other side of this panel, so not a big deal, not a long run or anything like that. And we got some nice beefy bus bars back there. And then right above it here, I've got the MPPT, and I've got the DC to DC charger. I've got the DC to DC switches. This is an on and off switch, and then that's a 30 amp / 60 amp switch. Then I've got my inverter power, remote power switch here. It also shows your inverter voltage, and I got my Wi-Fi module over here on the wall. So, and from here, I still have access to all the stuff that's going on behind here. It's quite a lot going on back in there. And then I have, in this other panel to the left, is where I have the DC bus bars. So anyways, going back to the Meanwell, it puts out what it promises, and it does it quietly, does it efficiently. It's not making a lot of heat. I love the fact that it's Meanwell makes really good products, really good quality products. So I think this thing will last a long time, and a big improvement for safety. And I prefer having it directly to the battery instead of running through all the DC panel stuff. Now, if you wanted to, power your system with no batteries, then you would need that running through the DC panel like the other one was. But I don't intend to ever have a situation here where we don't have batteries. So, there's just I can't picture any version of where that's going to become an issue. But if I ever did, I could always run a wire to jump to the panel. I suppose if I was going to, look for that situation, I'd have to rethink that. But as of right now, I actually prefer it this way because for another reason, which is when you turn on shore power, but you haven't turned on your battery switch for the solenoid, it lights up the battery switch, making you think that it's on. And that's another thing that was really confusing us at first when we started looking at this system. So anyways, guys, that's the situation in a nutshell. I got here's my dip switch settings here. I went for the 2-stage, and I wanted it to be 14.2. And that is right here, on, off, on, 2-stage, 14.2. As you can see, the lithium, they wanted to give you 14.6 volts, or if you go with the default, you get 14.4, and that's fine, but I'd rather do 14.2. I think that's smarter. There's no need to push your battery cells up that high to 14.6, because it would have to be absolutely perfectly balanced to reach 14.6. And this thing, when I tested it on 14.4 volts, once it got to 14.4, it kept putting out power afterwards, you know, up to like 14.42, and it kind of tapered off right there. So if you were at 14.6, and you know, that's, hopefully it would taper off before it got to 14.6 in that case. So I just switched over to 14.2, which is the flooded battery. But this thing doesn't have like desulfation or any of that kind of stuff. And if you go with the 3-stage here, you can choose a float voltage. I didn't want that either. I mean, I can still change it if I find out that I would have rather had the float voltage. But as of right now, I just wanted the simplest thing. And 14.2 volts is what we're aiming at here. All right, guys, if you have any questions, please post them up. Thanks for watching.